Hello, my name is Jacob Michalovich, and I'm here on behalf of our team to tell you all about the relationship between measures of dynamic stability and throwing velocity in college pitchers. The purpose of this study was to examine the relationship between measures of dynamic stability and throwing velocity in college pitchers. The overhand baseball throwing motion is very complex. When looking at this, we wanted to dive into those complexities. There are multiple muscle groups involved in throwing a baseball, and it's easiest to see this when looking at a pitcher. A pitcher is not just using their upper extremity, but rather they integrate their entire body into the throwing motion. We see in research that the legs and trunk generate the force of the pitch, while the forward tilt of the trunk makes the upper extremity travel a further distance, resulting in a higher transfer of force into the ball. A further understanding of the relationship between upper extremity mobility, dynamic stability, and pitch velocity can provide insight regarding conditioning and injury prevention strategies for the athlete, coach, and clinicians. There is a limited number of studies investigating trunk rotation and dynamic stability in baseball athletes. To be exact, there's three, and here they are. In 2016, Butler et al. Found that lower extremity dynamic stability, assessed by using the lower quarter Y balance test, differed based on a baseball player's competition level. However, they did not assess throwing velocity. Then in 2018, Bullock et al. Did not find a significant relationship between trunk rotational mobility, upper quarter dynamic stability, assessed by using the upper quarter Y balance test, and throwing velocity. Then also in 2018, Yanagisawa did not find a significant relationship between the dynamic stability of each leg, which they assessed by using the star excursion balance test, and maximal ball velocity or pitching accuracy. There's a lack of evidence supporting the role of both upper and lower extremity dynamic stability in throwing athletes. This study utilized the designs of previous research to investigate which measures of dynamic stability would be helpful in predicting throwing velocity. The three hypotheses that we drew were: there's no significant relationship between lower extremity dynamic stability and throwing velocity. There is no significant relationship between upper extremity dynamic stability and throwing velocity. And there is a significant relationship between lower extremity dynamic stability with added trunk flexion and throwing velocity. We drew a sample of 16 male college baseball athletes with an average of 14.3 plus or minus 2.6 years of playing experience. We took these athletes one day after their morning workout to assess their dynamic stability. The lower extremity dynamic stability was assessed by using the lower quarter Y balance test. To find the upper extremity dynamic stability, we assessed by using the upper quarter Y balance test. And to assess lower extremity dynamic stability with trunk flexion, we assessed by using the modified star excursion balance test with hand reach and trunk flexion, which we called in our research the hand reach star excursion balance test. Then, over a 2-day span, we clocked and recorded each athlete's pitching velocity using the previous researcher's standard radar gun. The relationship between the composite scores for the right and left limbs for each dynamic stability test and throwing velocity was investigated using the Pearson product moment correlation coefficient. As for our results, we found that there was no significant correlation between composite scores for the lower quarter Y balance test for the right and left lower limbs and throwing velocity. Thus, our null hypothesis was not rejected. We also found that there was no significant correlation between composite scores for the upper quarter Y balance test for the right and left upper limbs in throwing velocity. Again, our null hypothesis was not rejected. Then sadly, we also found that there was no significant correlation between composite scores for the hand reach star excursion balance test for the right and left lower limbs in throwing velocity. So our null hypothesis was rejected because there was no significant relationship between the lower extremity dynamic stability with trunk flexion and throwing velocity. These results suggest that lower and upper extremity dynamic stability are not directly related to pitching velocity. We suggest looking into the correlation of throwing velocity and force generation of the hip abductor and adductor muscles, though further research is still needed to determine which characteristics of dynamic stability contribute to pitching velocity performance. And that is our research. Just want to take this time to thank the athletes who participated in the study. I want to thank the coaches who supported us in collecting our data, especially during their season. I know it was a kind of a squeeze to get us in there, so thank you, coaches. And we want to thank Corbin University for providing all of us with the opportunity to conduct our research and present it here with you today. And lastly, we just want to thank God for allowing us to be here at Corbin University so that we were able to do this study. I know all of us had a great time with it, and I'm so glad that we were able to do the Science Symposium online this year so that we could share it with you all. You all have a great rest of your day.